Hello everybody, welcome. Today I wanted to show you something pretty interesting. I would like to go through a tutorial where I show how to create a fully decentralized data marketplace. So the good traded in our marketplace, it's going to be the data stream from IoT smart devices. The sellers in our marketplace will be the device owners that will register their devices in our marketplace. And then the buyers will be the users that will subscribe to a specific device's data stream. So before we get to the code, I wanted to invite you to stick around until the end of this video, because after we finish coding this marketplace, I wanted to talk a little bit about it. I wanted to point out some of its limitations. I wanted to talk a little bit about the conclusions that could be drawn from coding such a contract. In particular, about the relationship between IoT and blockchain and what IoTeX is actually doing in this regard. So let's get to the code, and I hope you enjoy it. So let's go ahead and open a project. I'm opening it in VS Code. I created a truffle project. You can see there are a few other contracts here besides the marketplace.sol. I'm inheriting from these contracts in order to have certain functionalities, like, for example, the only owner modifier that I inherit from Ownable. If you like to have a more detailed look into these contracts, I will leave the link to the GitHub repository, and if you'd like to also dig in a little bit deeper into all the concepts and everything that we're talking about today, I will leave the link to the article that I've written that's related to this video. So without further ado, let's get going, and let's start by importing our contracts that we will need. So we're going to import Possible, and we're going to import SafeMath. Possible is also inheriting from Ownable, so we get two birds with one stone in this case. So let's go ahead and create our contract. It's going to be called marketplace, and marketplace is inheriting from Possible, so is Possible. And here we go. Here we have our contract, and now let's get to it. The first thing that we're going to do is actually tell our contract to use SafeMath for the UN256. The next thing we're going to do is handle the global scope of our contract. So we're going to add a few events. We're going to take care of our storage by using a combination of mappings and an array of device IDs. We're going to have a few global variables, and then we're going to have two structs. One, it's going to be a device struct, obviously representing a device, and the other one is going to be an order struct, representing an order or a subscription to a specific device. So let's go ahead and add them to our contract, and then we'll look into them in a little bit more detail. So here we go. Now let's do this so we have a little bit more room. Now you can see that we have 4 events. So we're going to emit an event anytime a new device is registered in our contract. We're going to emit another event when somebody subscribes to a specific device, when a device owner claims their balance, and then when a device has been updated. So these are the events here. The next thing we're going to have is the storage. So the storage is basically going to be comprising of this bytes 32 elements array where we're going to store the device IDs. And then we're going to have the devices mapping, so that basically takes in a device ID and maps it to a specific device. Orders mapping follows the same logic, and then the allowed ID hashes is basically storing the hashes of the allowed devices in our contract. It's not quite storing, but it's basically pointing a device ID hash to a Boolean that it's going to say true or false, meaning if this device is allowed in our contract or not. After that, we're going to have a few global variables. Basically, we're keeping count of the registration and subscription fee and the total amount of registration fees and subscription fee that then we could actually claim. Then we have a constant variable, that's the max duration, because we decided that the longest subscription that we are allowing is basically 90 days. After that, as I mentioned earlier, we have the device struct and the order struct. So let's just look at the keys real quick just to make sure we understand everything. We have an owner, obviously, for a device. We have a Boolean flag here that specifies if the device has or has had an order already or not. We have the frequency that represents the data frequency of this device, so how often this device is sending data to the subscriber, what the price is, and then we have the settled balance and the pending balance, meaning that the settled balance would be the balance that a device owner can claim at some point. The pending balance is the pending balance that this device is generating. And we'll look into the logic a little bit later and you'll see how these all come into play. We have some technical specs, so that's a URL string that will be added to a device, and then we have the two public key components, and in this case we are using RSA encryption. So let's just pause on this for a second. I'll tell you a little bit more about them as soon as we go through the order struct. So the order struct here, it's basically, we need to say, okay, this order is starting at this block, so that's a start height. It's going to be lasting this amount of blocks, and that's the duration. And you can see these are both Uwin256. And then we're going to, when we, for example, when somebody subscribes to an order, they need to specify the storage endpoint and the storage token. So how they're going to do that? They are basically going to provide a storage endpoint and a storage token for the device, and these strings are going to be encrypted using the RSA public key components of the device itself. So the logic here is basically that the device is the only one that knows the private key that's associated with those two public key components. So it will be the only thing that's able to decrypt the storage endpoint and the storage token so that it knows where to send the data, and it has this sort of momentary password, this momentary token that it can use to send the data to a specific subscriber. The next thing that we have in the contract that we have in the article that I wrote about this data marketplace is a constructor. We don't really need to put it because if we don't put anything in our constructor, then the compiler will do it by itself when we actually try to deploy this contract. So let's move on. We are going to have now three functions that are only can only be accessed by the owner of the contract. So in this case, it's me and you. It's us. So these functions are, I would say, pretty straightforward. We are basically setting up the registration and the subscription fee, and we are also telling the contract which device ID hashes are allowed in our contract or not. So you can see here that these are only owner functions. This is another modifier that we inherit from Possible that basically says that we can pre-register devices when the contract has not been paused. So the logic here is pretty straightforward. We're basically setting up this fee parameter, and we're assigning it to the registration and the subscription fee. Here we're basically updating the allowed ID hashes mapping, sort of like what I mentioned earlier, and we're saying, okay, this device ID hash is allowed in the mapping, and hence we put it to true. So obviously the requirement for that is that this has to be false at the beginning of the function. Otherwise, that means that the device has already been registered, pre-registered, and we don't need to do that again. All right, so let's move on. The next thing that we're going to do is to take care of registering a device. So the next two functions are going to be a function to register a device and a function to update the device. So right now we are taking care of the sellers in our marketplace. So the sellers, the device's owner, will be able to register a device in our marketplace and set up the frequency, the data frequency that they want, and set up the price that they want, the specs, and the public key components. There's going to be some logic with it. We'll go through it. And then the other function will allow a device owner to update their device if they want to. So let's look at the registered device function and make sure that we understand everything, and then we move on to the update function. Okay, so as I said earlier, in order to register a device, obviously you need to know what device you're talking about. So that's the device ID right here. And the device ID could be, for example, an IMEI number. It could be a serial number. It could be, it's a unique identifier for that specific device that we want to register. So obviously know that, for example, here when we were pre-registering the devices, we were using the hash of the device ID in order not to expose the ID. But here where, for example, the device owner is using the device's unique identifier, because we assume that obviously they own the device and they are in possession of that information. So when we register a device, we need to then set up the data frequency, the price, the specs, like I said earlier, and the RSA public key components. There is going to be quite a nice checklist of things here that need to pass in order for our function to keep moving forward. The first thing that we need to double check is if the hash of the device ID that we are putting into this function is actually allowed in our contract. We need to check that the device has not already been registered. We need to check that we are providing the public key components. We need to check that the frequency is actually greater than 0. So I'm going to remove this because we don't want to register a device that basically has 0 data frequency, right? The next thing we're going to do is to make sure that the specs are there and that the value that we are sending with this function is at least equivalent to the registration fee that the contract owner set up when we did set it up just a couple of minutes ago. So at this point, if everything goes well, everything passes, we move on, and what we're going to do is obviously add the value that's sent with this function to the registration fee total that then we as owners will be able to redeem later on. We need to then set the allowed ID hashes for this specific device ID hash to false in order not to allow somebody to register the same device more than once, because obviously if you set this to false, then line 80 here will fail when you try to re-register the same device. After that, we are taking care of our storage. So basically we are creating a new device following the keys here that we had put in the struct, and then we are assigning it to the device's mapping for this device ID, and then we're pushing this device ID into device ID's array. And we'll see how, for example, the device ID array will come into play just a little bit later. And for now, it's just a good way of keeping up with the storage of our contract. After this is done, we're going to emit a registered event that basically says that this device ID has been registered by this user, the message.sender that basically sent this function. If everything goes well, we return true, and then we can move on. So as I promised earlier, the next function that we're going to look at is the update device function. So obviously only a device's owner can update their device, and so we need to put a check for that in our require statements amongst a few other checks that are sort of similar to what we just looked at. So if we look at the update device, obviously we need to specify the ID, frequency and price specs, and sort of similar to what we had earlier. We need to see here that the device has actually been already registered. We need to see that the person calling this function is actually the owner, that we are providing the public key components, the frequency is not 0, and that the URL specs, the URL with the specs is there. Okay. Now, once we pass all these, we need to move to the logic, to the body of this function. So at this point, this function wants to know one thing. So wants to know, has this device had an order already? And if so, we need to double check that this order has been completed. And so this is what we're doing. We're checking if this device has an order, and if so, we need to check that basically the starting block plus the duration of this subscription are less than the current block number. And otherwise, we're just basically going to throw an error. So if this passes again, then we're going to update the device mapping by updating its the keys of this device, and then emitting the updated event that says that this device ID, or obviously this device, has been updated by message.sender. Okay, so far so good. The next thing that we're going to do now is to take care of our buyers. So our buyers are obviously the users that will subscribe to a specific device's data stream, and so we need to create a function that would allow them to do so. So let's go ahead and add this subscribe function to our contract, and then we'll go through it just like we did for the previous functions. So in order to subscribe to a device, we need to obviously specify which device we want to subscribe to, how long we want to subscribe to this device for, and then we need to specify the storage endpoint and the token. So where this device is supposed to send the data. Just like what I mentioned earlier, where we were talking about the relationship between the public key components and these storage endpoint and storage tokens. Again, we're going to have a few require statements that I think are pretty straightforward at this point. We need to make sure that this device exists. We need to make sure that the storage endpoint is there. We need to make sure that the duration is appropriate, meaning it cannot be 0 and it cannot be more than the max duration that we had established in our global scope of 90 days in this case. And then we need to make sure that the value that we are sending with this function needs to be at least equivalent to the sum of the subscription fee plus whatever amount this device owner wants for the subscription, which is basically the duration times the price per block for this device. And notice that, for example, here we're using safe math, so for multiplication. Now, let's move on into this block of logic here that goes from 144 to 154. And what we're doing here is basically saying, okay, let's see if this device has an order already. And if it does have an order, we need to make sure that the order has been processed. So kind of like what we did before, that the subscription is not active. And it's basically the same thing that we did just a little bit earlier. The next thing that we're going to do is then say, okay, great. So this device had an order, and all we got to do is basically then update the orders mapping for this device, provided that this order has been completed. And so what we do is say, okay, so this order is starting now at this block number, and this is the duration, and this is where you need to send the data, and this is the token that you're going to use to send this data to me. Me being I'm subscribing to this device right now. So the next bit of this if statement is the else part, and basically what we're saying is, okay, so if you've had an order, that's what you got to do. We just mentioned it. If this device had never had an order, what we need to do is say, okay, now we set the mapping to true, or at least the has order property to true in the devices mapping, and then we are basically creating an order for this orders mapping. The next thing that we're going to do once we take care of this is to obviously update the subscription fee total by adding the subscription fee that the subscriber is paying for this device. And now we need to take care of the balance. So what we need to do now is saying, first of all, we need to double check that this device, if we need to make sure that this device either has or doesn't have a pending balance. So a pending balance is a balance that this device has accumulated that has not been basically added to the settled balance, which is the balance that then will allow, for example, a device owner to then claim these funds. So if this device has a pending balance, then we're going to add this pending balance here to the settled balance. And if this device does not have a pending balance, we're basically going to establish the pending balance as the value that is sent with this transaction minus the value that we are paying for the subscription fee. We emit the subscribe event and then we return true if everything went smoothly, as I am sure it did. At this point, we are now going to take care of two more functions. So the first function is going to allow a device owner to claim their funds, the funds that have been accumulated by the subscription to their device. And then the other function is for us as contract owners to collect the fees that have been accumulated while these people subscribe to a device, or maybe while these device owners register these devices into our contract. So let's go ahead and look at the claim function, and that's this is for the device owners. Let's see what is going on. Payable. Okay, no problem. So message.sender in this case is not pay. Okay, so we just do as it says, and now we should not be mad anymore. Okay, so the first thing that we need to do here is basically tell the function that we want to claim the balance for this specific device here. We need to pass a couple of required statements that are very similar to what we have already done. Then we need to double check if there is this pending balance, sort of like what we did earlier. And so if we do have a pending balance, we add it to the settled balance and then we set it back to 0 because obviously we have added it. So we've sort of like moved it to the settled balance. So we set it back to 0. At this point, we're going to take care of the transfer event, and the way to do that is to first create a new local variable that's called balance, and we're basically pointing the settled balance to this balance local variable. We need to require that balance now is more than 0 because we don't want to spam the networks with 0 transactions, basically. And then at this point, these lines are very important here. So before initializing the transfer to the message.sender, so to the address that called this function, we need to then set the balance, the settled balance, to 0. And this is done in order to avoid, for example, a reentrancy attack. And if you'd like to know more about it, I've written a little bit on it in the article that's related to this video. Otherwise, you can Google it. There is plenty of material about reentrancy. And so this is a very important thing to keep in mind, and it's a pretty standard procedure at this point. After that, we can emit the claimed event that says that this device has been, the balance from this device has been claimed by the message.sender, and this is how much they claim, balance. The next function that we're going to look at is the collect fees function, and this function is for us contract owners to, and again here is going to complain, but we need to just do the same exact thing. So we just tell it that this address is payable. At this point, we need to say, okay, this function can only be called by us, the contract owners, and what we need to do is set up the total that is the registration fee total plus the subscription fee total. We need to make sure that the total is not zero, kind of like what we did earlier. We need to then set these totals to zero before then transferring the total to the message.sender, which in this case will be us. Okay, so far so good. I think we're doing pretty well. We have now 3 more functions to go through before maybe we wrap it up and just think about a few conclusions for this marketplace contract. So now these functions are going to be view functions, and they're going to help us, for example, to retrieve some device information by ID, or maybe retrieve a device order by ID, or maybe allow for pagination when trying to get the device's ID. For example, that could be useful when our marketplace is very successful, and then all of a sudden we are dealing with incredibly large amounts of data, and we don't want to display all the IDs associated with this marketplace all at once. And so we sort of create a little query, a little pagination mechanism. So let's go ahead and look into that actually first. So this is going to be the get device IDs function. So it's going to take in an offset and a limit. An offset is basically where this query is going to start, and a limit is the amount, the number of elements that this array that we are returning, this IDs array, is going to have. And this is where we're basically setting the limit, the number of elements for this array that we are returning. And so all we're doing is basically creating a for loop where we are assigning these elements that are found in between offset and the limit that we have decided earlier, and assign them to basically each of the elements of the IDs array. And so in this case, we're going to then return count, so the number of elements, and we're going to return the array of IDs that we specified. So that's pretty straightforward. The next thing that we're going to do is look at these two functions together, because they're actually very similar. They follow more or less the same logic. So these are the get device info by ID function, and then the get the device order by ID function. So all we're going to do is make sure that the device here actually does exist, and if it does exist, all we have to do is basically create this new variable called D, which is basically a device variable, and then all we do is basically assign the device. So we take the devices mapping for the device ID that we specify in the function header here, and we assign that to this D, to this device variable. And then at this point, all we're gonna do is return the keys associated with that device element. So that's pretty straightforward. The same thing is going to happen when we try to get the device order by ID. So again, we need to specify the device ID here, make sure that the public key components are there and the device actually does exist. And the only difference is that here we need to basically say, okay, does this device have an order? Because some devices might not have an order, right? If this device has an order, we follow the same logic as before. If this device does not have an order, then we just return basically an empty order. And so this is it as far as the coding of this marketplace goes. Obviously, consider that this is sort of like a theoretical approach. There are a few limitations. For example, there are a few things that need to be that you need to be thinking about as a developer of this contract. I pointed out a few in the article that's associated with this video, and I just want to briefly go through them with you here in the video, and you know, maybe spark some thoughts or spark an interesting conversation at the end of this tutorial. So the first limitation that I wanted to talk about is the specs argument that is provided by the device's owner when they're registering a new device into our marketplace. So obviously, as a subscriber, for example, it would make sense for you to want to know the technical specifications of this device that you're subscribing to. But at this point, the way that this contract is set up right now, there is no way for you to actually trusting that the data or these specs are actually legit. So this is partially a limitation with the way the identity of a device is registered by only recording its unique ID. So this ID should somehow be linked to a proper identity document that actually provides the specifications for that device, and that is actually signed by the manufacturer or a trusted party. The other limitation that I wanted to mention is the proof of a device's ownership. So when we think about it, this contract is actually providing a level of protection by expecting that the manufacturer pre-registers a device based on their hashed ID. And this is done so that, for example, nobody could actually come and have access to these IDs just by looking at the contract's data or just by looking at the transactions. And therefore, they would not be able to register a device without actually owning them and knowing these IDs. But what happens if a malicious user would actually be exposed to or would get off-chain access to a device's ID before it's actually registered by the owner? In that case, they would actually be able to register the device in our contract and collect the subscription fees without actually being in possession of the device. And so this is definitely a limitation, but it could be actually overcome using a challenge response pattern based on digital signature and secure hardware. Now, last thing I wanted to talk about is actually trying to consider this contract in the context of a fully working data marketplace. So if we think about it, what we've done so far in this video, we've basically coded a smart contracts for a marketplace that does actually handle the exchange of data and funds trustlessly, and that's great. But in the data itself is actually never sent to the smart contract. And the reason for that is that the blockchain is actually not a practical storage layer for big volumes of data, and it cannot manage the post-processing that is required often in IoT applications. And so the fact of the matter here is that the blockchain layer alone, a layer one solution alone, is usually never enough when trying to use real-world data with decentralized applications. For example, the marketplace contract that we've just coded cannot really decide how and if this data was actually delivered to the buyers, right? So the claim function allows the device to claim their balances, but it doesn't know. It has no way of knowing if the data was actually ever sent to the subscriber. And this is the problem of a proof of data delivered. Another limitation is actually about the data itself. It's about its origin and it's about its integrity. So even if you, for example, let's say that you actually did receive this data as a subscriber, how can you make sure that this data actually originated from the device that you subscribe to and that this data hasn't been tampered with on its way from the device to you? And so these are very important points, and there are other important things like data privacy and security that need to be taken account when building these applications. And these applications, as we call them, are basically machine-fi applications. And the bottom line here, like I was saying, is that they require layer 2 technologies, and they require trusted hardware that generates verifiable data. And that is the bottom line. And that is actually what the focus of IoTeX is. Because IoTeX is not only a layer 1 blockchain that's built to serve machine economies, but it's also layer 2 components, hardware designs, and developer tools that facilitate networks of machines and the financializations of smart devices and machines utility and machines data. So it's a little bit of a complex discussion, and we're just scratching the surface here. And I just wanted to mention it because when we're actually thinking about this marketplace in a more broader term, in a more 360 degrees way, then we need to think about stuff like this, especially if we think of this in production terms. So I'm going to leave the link to the code that we went through for the marketplace and the article that's basically related to this tutorial that goes in a little bit more detail about the code and about some of these concepts as well. And I hope that these final conclusions spark some curiosity in you to go and check out some of these solutions, maybe check out MachineFi or check out IoTeX. And I wanted to thank you for sticking around so far. I hope you had a good time coding this with me, and I'd like to see you next time. Thank you.